think we'll get started. I'm Larry O'Brien of ARC Advisory Group. I'm not Mark Sengupta. He unfortunately had COVID and couldn't make it, but he's okay. I've actually been following ABB for a long time. I know Brandon and Mark, known them for a long time. So we have with us today Brandon Spencer, who's Division President of Energy Industries, and Mark Taft, who's Group Vice President for PA Process Control Products. We're really going to talk about the business value of technology today and how technology is evolving in the DCS or process automation system space. ARC has always been a big proponent of the business value of technology. Technology should not be purchased for its own sake, but for business value. And I think that's what we're going to talk about today. And I think, after following ABB for about 30 years, they are one of the best companies in providing that business value. I remember back to the days when they first introduced this concept of industrial IT. I don't know how many people in this room remember that, but they were one of the first companies to really put that idea out there that we can use commercial IT technologies in the world of automation for good and to provide a lot of business value. And I think we're going to expand on that discussion today, and we're going to talk about where things are right now and where they're headed. So I'd like to start by introducing Brandon Spencer, who's going to talk, really set the scene on evolving markets for automation. So without further ado, I'm going to hand it off to Brandon. Thank you, Brandon.
I appreciate it, and appreciate you all investing a few minutes here this afternoon while you have lunch here to spend time with us. Maybe a little different presentation. I sat in some of the work groups yesterday, or some of the presentations yesterday, and there was mathematical formulas and different things in some of the content. We don't have any of that in our slides today. And so maybe we touch a little bit more on the markets and kind of the direction of travel. And I was asked in a media interview earlier today, kind of my thoughts of the conference and what's going on. And I said, it's a super exciting time to be in automation. And I spoke, we had a capital markets day, which is where we go present to all of our shareholders and analysts and stuff. And I spoke at that 2 weeks ago. And I said that, automation isn't a dinosaur and our industries aren't dying. And so I think it's a really exciting time for us. Automation is a big enabler for what we're also talking about across the digital landscape. And so I'll touch on a few kind of broad topics. Happy to take questions and this sort of stuff, and certainly happy to have Mark here with me today. So I won't go backwards in time too much in terms of where we are in automation. One of the sessions I sat in yesterday was around autonomous operations and the different level 0 to level 5, where things stand and kind of the journey towards that. And there's different scopes of how autonomous things will ultimately be. I was with a customer in India, and he told me, hey, no matter how much you automate this plant, no matter how autonomous you make it, I still have to employ a certain amount of people in this facility because of requirements from the communities that they operate in. So certain places obviously are going to push it further. Other places, there's other requirements. And so this is a little bit about the journey from manual and going out and turning valves and on walkie-talkies and this sort of thing to AI. And Mark will show a great video today of how we're kind of getting to that level 4 range that was talked about during the autonomous session yesterday in our control systems now, with things detecting an anomaly, self-correcting, self-healing, making recommendations for the operator, these kind of things. And so we'll certainly touch on that as we go. Kind of what are the drivers? The changes in end markets. This is a super interesting topic for us. My business covers power and water, oil and gas, chem and refining, energy transition, really everything across the whole heavy industries landscape. And so that's the business I have the fortune of leading. And if you look at what's changing in the end markets, now we've got huge changes in electrical infrastructure in these facilities. You've got sites that are going to have hybrid power systems. It used to be either a grid connection or a power island, and that was it. Now they're integrating renewables. They're integrating battery storage systems, all these sort of things. We've got not only end customers, like I see in the room with some people from ExxonMobil and from Dow and from other places that have big engineering departments and these sort of things, But a lot of our new customers are private equity, where they're trying to monetize a commodity. And so it's a different way of operating. It's a different design philosophy. It's about speed to market. Innovation, they'll embrace it as fast as you can bring it. So it's not really yesterday's technology tomorrow. It's more about what can you do for me now? How can you help me make this more efficient? And so that's certainly changes that are happening in our end market. Technology and digital evolution / revolution. I mean, there's a lot of buzzwords that get thrown around with digitalization. I think everybody's still trying to find their way of how you add value, how you really create something that impacts you all's bottom line. And not, I mean, dashboards and all this stuff, okay, anyone can do all that. But how do you do things and application-specific things that really drive value and help your bottom line? And then workforce changes. And the story I always tell here, I have 2 kids. One is 14 and one is 12. And when my daughter was little, I had my computer sitting on my lap doing email, and she walked up and swiped her finger across the screen. You know, that's not how that technology worked. I was talking to someone at a conference recently, and they said that their kid, which this is a little bit sad, quite honestly, but their kid, there was a butterfly in the window, and the kid went up and tried to expand the window, right? And I thought, oh my God, we've probably crossed over a little bit too far. But the workforce expects different ways to operate. Operating the way we used to operate is not going to be satisfactory to the next generation. And there's a graying out that's happening in our application expertise in you all's companies. It's going to happen that people will get to that well-deserved retirement. The next generation isn't going to settle for how things are being done today. And we see that all over the place. So I think the workforce changes is going to be absolutely a catalyst to drive change. Sustainability, energy transition, ESG, all these kind of things. A couple things that I want to mention from this slide. If you look at 2020, if you look at 2030, so kind of go out 8 years from now, fossil-based energy will still be the #1 source of energy. The first transition that happens in the energy transition is that gas overtakes oil. That happens in the late 2020s sometime, 2028, 2029, whenever that is. So the first transition of energy transition is that gas overtakes oil. Then gas is the leading horse for decades. And so I think it's really important that we not throw cold water on the energy transition. We absolutely support it at ABB. You know, we're doing things in the marine business, we're doing things in the EV business, we're doing things that electrify across industries, hard to abate segments, all these sort of things. But we need to have it grounded in some reality, and regardless of what source you look at, whether it's IHS or IEA, any of the analysis that you look at, fossil fuels will be the leading source of energy, even if you go out to 2050 and beyond. And so we have to take care of our current customers. We have to be part of that transition story, and I think that's an important part that we're playing. But something that's nice, that's common across these industries, and I'll dive into this a little bit, but the things that you see on the right-hand side of the screen there, minimizing emissions. You know, the greenest unit of power is the one you don't consume. That's what we always say at ABB. And so everybody wants this silver bullet that solves all the problems. There's a lot of things you can solve right now. 45% of the world's energy is consumed through electric motors. If you make those high efficient, what happens? You get 10% extra capacity into the grid just by changing motors. So we can get there. It's a journey, right? We don't solve it overnight, but we can get there. And so I think decarbonizing, scaling technologies, and then the last bullet I think is really important and a little bit of a change for our industries. I was at Siemens for 6 years in power generation, gas turbines mainly, and then 16 years at ABB, largely oil and gas, mining metals, et cetera. And facilities that can adapt, I think critically important, because some of these customers that are coming in now, the feedstock might change. The product they're producing might change. And so it's not necessarily one thing in, one thing out. Now it's about facilities that can adapt. So how do you do that? What does that look like? And automation plays an absolutely key role, along with digitalization, across those things that you see on the right-hand side of the screen. So if we look at the markets, coal certainly in the decline. A little bit of a renaissance now, certainly with energy security. And so you see a little bit of that happening. even in places in Europe and different places where they're saying, hey, we're going to cut these coal units back on and different things because of the war. Oil coming towards its peak. If you look at what happens next, all these other industries that are getting oxygen that are growing, all of these industries are GDP plus growth. And so a lot happening in water and chemicals and natural gas and shipping and mining. You know, you can't electrify the world without mining. A lot of people don't unnecessarily connect those dots all the time. And so, so these industries are growing. And then, of course, there's the exciting industries, right? The stuff that gets all the press and all the news, all the headlines, but it's not to scale, not yet. I mean, you take green hydrogen. 75% of the capital in green hydrogen is around electrification and around losses that happen across the value stream in electrification. And so getting that to scale is not necessarily an easy problem to solve. You know, we'll cover a few examples where we're doing it. Carbon capture. Carbon capture has been around a long time. Sequestration, pumping it back through gas turbines, all this stuff that's been around for a while. Now it's getting legs. You know, eventually there will be some carbon tax and things that make sense from a legislation standpoint that help it move along, but it's definitely happening. And we're seeing this integrated into facilities where they're saying, hey, we're going to do our own carbon capture as part of the initial project. That wouldn't have happened 5 years ago. So really dynamic changes across our market, but the message that I want to leave you with is that for all of us in the room, there's a tailwind. And you can't do any of it without automation. And so what's happening with automation? The facilities are certainly, if you look at unmanned or autonomous and the journey towards that, and there's been lots of talks at this conference about that. Automation is a key enabler for that. And so we have plenty of examples where we're moving towards that, or unmanned platforms, all these sort of things. As you look at now measuring emissions per barrel, or different items, different KPIs that in the past were never measured. Or maybe they were measured, but they weren't on executive scorecards. Now they're on executive scorecards. So that changes the whole game. If you look in the middle there about the complexity of facilities, John Plumley presented earlier today about Grand Fuels. And so that's a picture of Grand Fuels there in the middle. 60 megawatt battery energy storage system, carbon sequestration, multiple power sources. These are becoming more complex. And so, you know, a great strength for us at ABB, not to give a commercial here, but a great strength for us at ABB is certainly the blend between power and automation, and doing those in a single system, a single engineering environment, a single pane of glass. And that is going to become more important because the electrical infrastructure is only increasing. And then that leads to kind of the last point there. You know, electrifying mines. You have to redesign the whole layout of how that facility is set up and how it's constructed. As you all are building and designing new facilities, you're going to have to design them differently when we go forward. And so the combination of these things is really critical, and we certainly think it's a great strength for all of us in automation. Mark's going to step through a few things next around the technology and the direction of the technology, enablers, where it's going. And so with that, Mark, I hand it over to you.
Thank you. Yeah, I'd like to start maybe talking a little bit about the technologies that we have today and how far we've come. And I think it's important to look at that from a standpoint of this is the foundation that we're going to be moving from for the next generation of automation technology as we see it. And I want to start with a concept that we introduced probably 20 years ago now called extended automation. And what extended automation does is we use our aspect object technology to allow customers to open their systems to the power of integration. Allows them to take an asset at any level of the plant and create a digital representation of that asset, which will of course include all of the things that you would normally see in a DCS, the control logic, the visual representations, the alarms, the events, and historization. But the important part of it is it allows them to integrate data and information from other systems, making that available to the user in this digital representation. Things like maintenance management systems or engineering data, standard operating procedures. AutoCAD is another one that's often used. So that when an operator or someone else is evaluating a situation and trying to figure out what to do, this information is all available to him with a single mouse click, allows him to very quickly make a decision about what to do, but also be able to perform the action very efficiently. And really, this is kind of where the beginnings of what we now call augmented operations began. Our systems today already support remote and cloud-based engineering. I mean, our engineering people around the world are using that today to execute projects, and we use that as a collaboration tool with EPCs and engineering firms as we execute projects. And we introduced this concept of remote operation and remote expert support in the North Sea more than 10 years ago. And of course, in the last couple of years, that's become more and more interesting to more and more customers because of what we've been through with COVID. Brandon mentioned the electrical integration. I mean, it's natural for us with the broad scope of supply that ABB has in the electrical field for us to provide the integration of those two worlds in a single place so that customers can be more efficient at running their facility. And I think perhaps one of what we feel is one of the biggest differentiators and one most important thing that we've provided to our customers is that as we have introduced new technology into our systems, we've done it in such a way that our installed base customers can make use of that, can add it in a stepwise fashion according to their needs, and can retain the intellectual investment that they've made over the years in their applications as a foundation for them to make use of that new technology as they move forward. So a lot of great things already available, already in use. And so what's the result? The result, ARC has recognized us at ABB as the #1 automation supplier now for 22 years. We've assembled an installed base of over 100 million I/O. So a lot of good stuff, but there's more to be done. So I would like to share with you a video to give you a little glimpse of one of the things we're working on, and I think it will help us to transition to more of a discussion of what's coming in the future.
One of these cases might be an anomaly in one of the separators. Now, while you're sitting here and controlling the plant, suddenly something in the background is happening.
Process needs your attention. Process values start to deviate from normal operation. No alarm yet.
So as you have heard, an artificial intelligence from the back suddenly pops in the foreground and is telling the operator something is wrong. You don't see any alarms up here. So the plant itself is still in steady state, but something has been marked around here as getting out of the normal. And also the artificial intelligence has told us, please take a look. And now we take a look at what's wrong. And it first of all has already highlighted the area over here. And you can see two valves next to each other. One is marked a little bit red. And you see the same thing over here, the separator, one main drainage valve, and a second standby valve. Now what can you do as operator next? You will hit the Analyze button here. And now the artificial intelligence in the back is showing you monitoring different signals around the separator that something is wrong. You have an anomaly indication here that tells you that one of the signals is behaving different to where it really should be. All the other ones here are somewhere in the normal range, but this one is sticking out as an anomaly. Now you need to dig a little bit deeper to figure out what's wrong with this particular valve here. And the next question is, okay, if that valve doesn't operate as it should, is this something that we have seen before? And you ask the system, has this happened before? And luckily, it found at least one occurrence on 23rd of April last year, where suddenly one of the valves got stuck and things started to move away. So now at least the operator, even though there is no alarm yet, is realizing somehow the things are moving. We are gearing towards something where I will have an alarm soon. So what can be done now to overcome the situation? And the system now proposes two strategies. So now there is one strategy with a bunch of steps in there, the second proposed strategy. One of them is marked as has been successful in the past. And as an operator, you read through and you would say, yeah, maybe that is closest to what would fix the problem to happen. And then before you really deploy this, because now if you do things wrong, you might end up with a surprise and finally a shutdown. You don't want to have that. So if the system would allow you to look a little bit in the future and simulate, if you execute, how would the plant react? That would be an excellent help for making your decision, your final decision. We execute this, and now you can see that the first valve here that was operating so far is closing down, and the standby valve is gradually opening. You also see this here in the trend of the real plant. So this is modern process control and operations, where a few operators in the facility or even remote get an assistant from the system to overcome abnormal situations.
Okay, so where do we think the automation technology is going in the future? What is our vision? And before I start with that, I think it's important to recognize that, at least from the way I view things, our customers are more active today in collaborating with one another to give us insight as to what they think the next generation of automation systems should look like, and perhaps even more importantly, how they want to use them in the future. And so when I listen to what they have to say and what they're working on, there's two things at least that pop immediately into my mind. The first thing is, it's pretty clear that they want our next generation automation technology to carry with it a much, much lower life cycle cost. The second thing they want, and perhaps this is even more important, they want an automation ecosystem that allows them to be much more agile in innovation than we've been able to deliver to them with the technologies that are available today. So what does that mean? I think the first thing we see is that means a much flatter architecture, network-based, which will allow for much easier access to data on the plant floor by optimization programs or IT systems. If a piece of information or data from a device or an instrument is not necessary to be used for process control, then there's no need to route that through a process controller as we've had to do in the past. It'll be directly accessible, much more agile, much quicker, much lower cost to access that information. This ecosystem, the customers would like to put together solutions with best-in-class technology from various suppliers. They don't want to buy everything from one guy. And with the maturity of the OPC UA standard and the companion standards, this is going to become much more practical than it has been in the past and much easier to maintain as we look forward. Modularity will be key, and it's been mentioned several times here at the conference. A couple of areas I see for that. First of all, these systems will be comprised of relatively independent software modules with well-defined interfaces. So that'll allow customers to add, to upgrade, to replace, or even decommission an application without affecting the performance of the rest of the system and without having to upgrade the software for the rest of the system just to make that change. The other area that I feel is very important from a modularity perspective is the world of engineering. You know, when I started as an application engineer more than 40 years ago, when I was programming a control application, I was using a programming language close to BASIC. Maybe some of you here actually know what that is. And assembly language, and even in some cases, machine code. And over a beer, I'll tell you some of my experiences of programming in machine code. But, you know, shortly thereafter, the function blocks came out for the process control guys, the ladder logic for the electrical guys. We added structured text and we added SFCs. And then about 30 years ago, IEC decided that they would put together a standard that would define the various means and ways that you could program an automation system. 30 years ago. And there's been almost no innovation in that area since then. So we will deliver a system that will be able to be engineered at a higher level, putting together modular libraries that include, of course, all the various things you need for process control, but also to allow for that extended capability, connection to other outside systems. Pre-tested, pre-validated, should greatly reduce the engineering effort, should greatly reduce the testing and the commissioning effort, should make for a much more predictable result, and perhaps more importantly, allow the engineer to be focused on much more value-added activities and not down here programming in 1131 or 61449 or whatever you want to talk about. Finally, go back to this augmented operation. You know, again, we're being told customers want an environment where they can be more agile for innovation. So we think it's important that you protect the basic process control, leave that alone, if you will, and then the sandbox, if you want to call it that, up above for this continuous innovation would be separated from that, and therefore, if you make a mistake up here, the basic control continues to run. And that's basically, Nomura describes that in their open architecture concept. And finally, and very importantly, we will introduce this new technology in a way that allows our existing customers to make use of it, to add it to their existing systems, to retain that intellectual investment that they have made and have been adjusting over years as a springboard for them to innovate as they move forward. With that, I think I turn it back to you, Brandon.
Yeah, maybe Larry.
So that's a lot of change for a customer to deal with. So putting ourselves in the customer's shoes, Brandon, maybe we can explain a little bit and talk about what the customer needs and challenges are today and in the future.
Yeah.
Things are changing pretty dynamically right now. Everybody's adopting digitalization strategies and, you know, trying to become more and more agile and responsive and dealing with supply chains. So now where do we go?
Yeah, I think Mark touched on some of the topics for sure in terms of direction to travel or what's happening. I mean, on the left-hand side of the chart there, what you see is kind of the table stakes, right? You have to have a solution that runs with safety as a priority. You have to have reliability and the however many nines we want to talk about. You know, you have to have of all these things that you see there on the left-hand side. If you look at the right-hand side of the chart, a little bit more about what Mark said, those faster modernization cycles. When we're talking about chips, which is a big topic now, for sure for us in the automation space, you know, the consumer market has 6-month cycles. That's kind of the expectation in the consumer market of refreshing technology. We talk about 25-year cycles. There's a blend somewhere in there. And we have to figure out how we do that with less pain for you all as an end user. And how we fit it into how the plant's doing. The IT/OT blending, I think really important, and certainly as we talk about cybersecurity and other things, there's a lot of blending happening there, and certainly there's even blending happening in your organizations, where these used to be separate parts of the group, and now they're one group. And so figuring out what those turf wars look like, and then how that translates into technology, pretty important. The scalable piece Mark touched on, and then open systems. You know, we're not so egotistical to think that everything is an all ABB all the time. You have assets, you buy assets, you sell assets, different vendors, different topologies, different everything. Mark used the term best in breed. We think it's really important that our systems can interface to those best in breed. And if someone does something better than us, great. Let's use it and integrate it into our offering. And that's what 800XA, that's what our platform offerings are all about. Is yes, they're a control system, but it's an integration platform. It's the same thing we're doing in digital, where we're not trying to be out selling a platform. We're trying to enable the consolidation of these disparate systems into something that's useful for you all. So I think future requirements, Larry, certainly those are kind of themes that we would say, and obviously you could spend entire days on each of those.
Yeah, well, if you've listened to the discussion this week about data, Everybody's trying to get data from all these disparate sources. Nobody has clean data, right? We need to bring data into a common environment before we can actually make intelligent decisions about what's happening in all these different
Yeah.
areas of functionality.
Yeah, I mean, we're doing a lot of productization in ABB because we call it orphan software, where we develop something in this country for this customer, and then no one else knows about it, no other customers use it, it's a one-off thing, and then we develop something different in another country, and yet all these offerings are trying to solve the same problem. I'm sure you all, if you reflect, have that happening in your own companies as well, about these orphan software things, and so I think it's a really important part of what we're trying to do.
And I think also having an object-oriented system is a big help.
Exactly.
When it comes to stuff like that. Can you give us some examples of what ABB is doing today to address the customer needs?
Oh, there you go.
Yeah, sorry about that. They cut my mic. Okay, it's back on again. Just leave it on if you don't mind. So, can you give us some examples today of what you are doing to address these customer needs and help them progress to their digital transformation? Any use cases or some real-world examples would
Sure.
be good.
Sure. Mark, maybe you start.
Yeah, there's a couple of them I'd like to talk about. The first one is a Sidera project. Very impressive project, lots of firsts. And you can see the mention there of how state-based control allowed them to get through their reliability test efficiently and effectively. But I mean, if you were in the autonomous presentation yesterday, of course, you heard Jonathan talk about the value for state-based control. But if you weren't, I'd like to share with you a story. Way back a long time ago, Mike Williams and I were having a conversation, and Mike said to me, he was trying to explain to me what this state-based control was all about. And he said, you know, just think about it, that every process is a batch. The only question is, how long does the batch run? It could be run minutes, hours, days. If it's a continuous process, it's measured in years. And all of those processes have to go through similar transitions. You got to start them up, you got to ramp them up, you got to shut them down. And of course, there's the steady state where you're making your production, and that's where the focus for automation lies. So if you think about it, if you're going to start up a plant once every 5 years, the chances that the procedure to do that as written is still valid, or that the guy who has done it the last 3 times remembers everything that he needs to do, there's going to be some mistakes. And if you have a brand new operator who's never done it before, then you definitely have opportunities for error. So automating the states that today aren't automating certainly brings some value. And then, as was discussed yesterday, when you're in that steady state, looking for anomalies, being able to react to those anomalies, either with an action that's already pre-programmed or to at least give guidance to the operator, is incredibly valuable. The second one I want to talk about is INEOS, very near and dear to my heart. This customer, ABB customer for 20 plus years, and they started out with us with a technology which was the very last technology that I was allowed to program as an application engineer before I moved on to other things. And so there's something in my heart there about that system. But anyways, they upgraded it. And as you can see, it was a smooth upgrade, took place in 3 weeks, no surprises, no issues. But that's just the beginning of the story. They were able to carry, as I said earlier, their application forward, to use that as a foundation for improvement. And they were running a third-party software product that allowed them to provide data to people within the business who needed it from the plant floor. The problem was that application was extremely difficult to keep up to date. Every time there was a change made in the control system, someone had to remember to make the same change in the third-party system, and it was often out of sync. Well, come to find out, after they did their upgrade, that functionality was built right into their new system. And so very easy to use. No effort at all to keep it up to date, because whenever a change was made, it was automatically reflected. And so a great example, at least from my perspective, of what we mean by evolution without obsolescence. Back to you.
Yeah,
Bob.
maybe interest of time to make sure you all are on schedule for the next session. Just 2 examples that I'll cover. One, we launched something called adaptive execution about 1.5 years ago. And that's where we try and improve our execution methodology. So process, technology, people, and infrastructure. Take best in breed, try and make it work and deploy it. The Equinor example there of saving 40 days, 2,700 man hours at commissioning, that's when costs are highest, safety is the biggest risk, and time pressures are the highest. And so deploying a different way of doing the execution in order to get that. And then on the right-hand side is one of my favorite examples. We just had a press release on this yesterday from ABB. This is a refinery that was in Canada, now repurposed to do biofuels, and so sustainable fuels for transport, for air and for land. And now that facility gets life injected into it for another 30 years to do something different. So if you talk about circularity, you talk about energy transition, you talk about all these things, that's a real example of how automation is helping drive that happening. And so just a couple cool examples that are real things that are happening for our customers. So maybe, Larry, in interest of time, maybe if there's any questions.
Yeah, I just want to mention, these are some key concepts that if you don't know about them, you really should find out more about them. And they're all supported by ABB, state-based control, modularity, modular production concepts, concurrent engineering, all these things are worth delving into. We spend a lot of time in the process industries doing kind of rote tasks that don't really add value, and all these things can be automated. So it's worth finding out more about that. And we do have some time now to take some questions from the audience. So if anybody has any questions, please feel free to speak up.
No ABB people. No ABB people are allowed to ask.
We've got the experts here. You're at the forum, so take the opportunity and ask a question. And there's no such thing as a dumb question. So. Sure, here we go. Let me pass you the mic here. And just let us know who you are and where you're from.
Hi, I'm Nathan Hoisington-Shaw from Owens Corning, and do you have any experiences with some instances where there isn't a known automation solution available and having to either find a solution or work around it with your greater image of automation and your AI solution solving?
I mean, I think we do that all the time. I mean, especially in Brandon's business, I mean, his guys might be doing a refinery one day and a batch process the next. So I think there are, of course, we have libraries of solutions that we like to deploy over and over again. But when there's something new, then collaborating with the customer to figure out the best way to solve the problem that's our job.
Yeah, I mean, I think a great example. We have well-established libraries in metals, for example, or in pulp and paper. Now, in these new industries that I showed you earlier that are coming up the curve, we've now started to adapt those libraries for like battery manufacturing. So we're taking all the knowledge and application experience and everything that we have that's proven, robust, whatever, enhancing it and changing it for these new industries to help them come up the curve much faster. And so I think it's constant innovation that we try and do with respect to that.
Hi, Dave Hake with Armis. Brandon, you mentioned batteries just now and earlier in your first comments. But are batteries and EV charging in your portfolio or a different part of ABB? I ask only because I saw a great press release about a program across Shell Germany.
Yeah.
Certainly every country in the world and every big player is going to want to deploy EV charging and do it economically. So it seems like a great thread of new business, but is it yours or handled elsewhere in ABB?
Yeah, it's largely handled elsewhere. So in our process industries business, we run the battery manufacturing out of that. So Northvolt and other customers that we're supporting to develop plants. So it's run out of that, just kind of heritage of where it started. EV chargers and those sort of things are productized. So our product businesses sell those. Where my business comes in, we just won some orders in California and in Canada and other places where we're coming in and setting up the whole infrastructure. So, my brothers and sisters want to sell boxes, right? And move them around the world. but someone has to integrate it all and build the infrastructure. So whether it's in a mine, whether it's for commercial transport or whatever, where my business comes into play is solution delivery around that. But yeah, I mean, EV, you know, we're taking that business as an IPO for part of that business because there's huge capital available and a lot to be done in that space. So EV really important for ABB.
No other questions? We've got time for one more, if you're interested. Okay. I think
Thank
we're
you
probably,
guys. Yeah, thank you guys very much for spending the time with us. We appreciate
Yeah,
it.
thanks very
Just one final
One
advertisement.
last thing.
We didn't have a lot of time to have this discussion. We issued a white paper about 2 weeks ago that really describes in much more detail how we see the automation market evolving and what we are going to do to respond to that. So I'd invite you to stop by the booth. We can give you a QR code and you can download that if you're interested.
Yeah. Thank
All right,
you guys
sounds
very
great.
much.
Thank you, Mark.
Thank you.
Thank you, Brandon. Thank you all for coming.